Here we have what we call intersecting chords. So we can have intersecting chords on the inside or on the outside. So we can have two secants or two secants on the inside, or we can have a secant on the outside, or we can have a secant and a tangent on the outside. Okay, and regardless of these, we're kind of setting up proportions, and so that's kind of how they go. So we break down each one into two parts, right? So we say A times B is going to be the same as the other two parts, which is C times D. For the inner circle secant outside of the circle, we have the outside part, which is A, times the entire length of that chord or that secant line. And so the entire length of that chord is going to be A plus B, so that's what we do, A plus B. And it's going to be the same for the other part. So the outside part, which is C, times the entire length of that, which is C plus D. And the same for intersecting tangent and a secant. So here we have the outside part, which is A, times the whole thing, which is A again. So we say A squared, and that's going to equal to the outside part times the whole thing, which the whole thing is just B plus C. Two inside two intersecting chords inside the circle, so we multiply these two together. So 10 times x, and on the right side we're going to have 14 times 15, and so from here it's just a matter of simplifying. So 10 times x is just 10x. On the right side, 14 times 15 is 210. Divide both sides by 10 and we get x to be 21. For the second problem, we got to be a little bit more careful because that second part is no longer a single digit. It is now, we have 24 times x plus 7. On the right side, we have 27 times x plus 5. And so once we do that, we're going to have to distribute that leading coefficient into each one of these inside the parentheses. And so we had 24x plus 168, and the right side we have 27x plus 135. And so from here we're solving for x, so we're going to do a couple of things at once. We are going to subtract 24x from both sides, and at the same time we're going to subtract 135, and that's going to leave us with, on the left side, 33, and on the right side 3x. When we divide both sides by 3, we end up with x being 11. For the last one, we set it up exactly how we've talked about. So we have 8 times the whole thing. The whole thing is 8 plus 19. And on the other side, we have the outside part, which is 9, plus the entire thing. The entire thing consists of 9 plus x. From here, we're going to simplify and distribute, right? So distribute this 9 to both of these. Here I can simplify before multiplying, so we have 8 times 8 plus 19 is 27, and then we're gonna, on the right side we have 81 plus 9x, and on the left side 27 times 8 is 216, and that's equal to 81 plus 9x. So to subtract 81 from both sides, we get 135 equals to 9x. Divide both sides by 9 and we get x to be 15.